Right, let's start. So what are redox reactions? You guys already know what they are. So does anybody remember how do we define it?
A reaction where oxidation and reduction happen simultaneously.
Good job. Redox reactions are those reactions in which oxidation and reduction happens simultaneously. How do we define oxidation?
The loss of electrons.
Yeah. Is there any other definition for oxidation?
The increase in the oxidation state.
All right, fine. Anything else? So oxidation is loss of electrons or gain of oxygen or loss of hydrogen. So when we do talk about oxidation, there are three possible ways of defining it: as gain of oxygen, gain of loss of electrons, or loss of hydrogen atoms. So that is oxidation. And when you talk about reduction, what is reduction?
The loss of electron. I mean, the gain of electrons.
Yeah, exactly. And so
Or the
what?
loss of oxygen and the gain of hydrogen.
Hydrogen, exactly. So that is how you're going to go ahead and you can identify what your oxidation and reduction are. So we know what is oxidation and we know what is reduction. So when we are going to talk about it, I believe you guys already know how to write down your half equations from IG level, right? For example, if I ask you to write down the all right, for example, I give you guys, let's say I give you guys two half equation. First of all, even chess is possible for you to write on the screen. Can you write down what would be the equation for nickel? If nickel was, for example, if nickel was getting oxidized, what would be your half equation? Half equations you make exactly the same way as you do in your electrolysis. So the way you would make them in electrolysis, just like that. And all right. And so, okay, when you talk about over here, when you wrote down minus 2E, so if you remember from the topic of electrolysis in IG, when we used to write down equations for cathode and anode, we always used to try to write electrons with a positive sign. So your equation is correct.
Okay.
Yeah, that nickel will lose 2 electrons to become an ion, but we're not going to show the electrons over here. We will show the electrons on the other side of the equation, and we will write down plus 2E. So that would be your half equation.
Okay, right. Yeah.
Now, and can you write down one equation for the reduction of iron? Iron 3 plus. So if iron 3 plus is reduced into iron 2 plus, what would be your half equation? Iron 3 plus into iron 2 plus. Because iron has two oxygen states, 3 and 2. It doesn't have an oxygen state of 1. Yeah.
Sorry, I don't know why I did.
Right. So are you done? Complete?
Oh, wait, sorry.
Good job. Now, if I ask you to combine the two equations and come up with an overall balanced equation, how would you do that? So let's go ahead and see. Your equation number 1 is nickel, gives you nickel 2 plus 2 electrons, The second equation is iron 3 plus electron gives you iron 2 plus. These are your two major equations. So let's go ahead and see how we can possibly go ahead and balance them. So the way we can do them is this, that we have to balance the number of electrons. So whenever we're trying to balance our half equations and come up with an overall equation, we need to balance the number of electrons. So in the top equation, we have 2 electrons. So in the lower equation, we also have to multiply it by 2 to turn it into 2 electrons. So multiply the second equation by 2, I will end up getting 2 Fe3 plus 2 electrons give us 2 Fe2 plus. These electrons will cancel out because they are on opposite sides of the equal to, and they are both equal to each other, and whatever we are left with, that is going to be our final equation. So 2 Fe3 plus nickel, we put our arrow. Write down whatever is on the other side. Nickel 2 plus Fe. And this would be your overall total equation. Making sense?
Yeah.
So is this making sense?
Yeah.
All right, take another example. You have to construct a balanced ionic equation for the reaction of iodate ions with magnate ions in the presence of hydrogen ions. Okay, that is what you guys have to do. So first of all, please don't worry about it. I'm telling you. Write down an equation for me for your iodide ions turning into iodine. So iodide ions turning into iodine. What would your equation actually be?
It would be I minus becomes what do you call it?
Yeah, if you can write it down, that would be good.
Oh, yeah.
Iodide ions turning into, yeah, okay. Iodine. What is the formula of iodine, by the way? Yeah, good job. Good job. Are you done? Yeah, good. So this is the equation for iodine getting oxidized. That's step number 1. Step number 2, can you write down an equation for me for magnate ions? So you can go ahead and start. I'll actually write it down for you. Let's say we have magnate ions, MnO4, and they have a negative sign. So this MnO4 is actually gaining electrons. I'll write that down for you. And it is giving you Mn2 plus 4H2. So this is your equation for oxidation. This is your equation for reduction. The reaction is taking place between ion and magnate. What you guys have to do is take these two ionic equations and give me a balanced overall equation for these two. You have to combine the two half equations to give me a total balanced equation. So how can we do that? These are 5 electrons, by the way. So what do? We always want to balance the electrons. Can you guys tell me a possible way which we can balance the electrons somehow or the other?
We multiply the first equation by 5 and the second one by 2.
Exactly. Multiply the first equation by 5 and the second equation by 2. So what will become? This will become 10I minus gives us what? Okay, look, I'll write it down again. Look, you have two half equations. 1 minute. You have two half equations. This is one half equation, which is your oxidation. And this is your second half equation. You have these two half equations given to you in your question. They are saying combine the two half equations. So this is oxidation, this is reduction. Combine the two half equation to come up with an overall equation that is completely balanced. That is what you have to do. You have to combine the oxidation equation and the reduction equation to give the overall equation for the reaction. Is that making sense? Ozoya, is that part making sense? That what you actually have to do?
Yeah, I get that.
Okay, now what you have to do is whenever you are solving this particular question where they have given you two half equations and they're saying combine them and give us an overall equation. So one of the ways you can do that, or the only way you can do that, is by balancing the number of electrons. So you want to make sure that the equation at the top and equation at the bottom have the same number of electrons. So the top equation has 2 electrons. The bottom equation has 5 electrons. Can you think of a possible way that we can balance the electrons out?
Oh,
Yeah, so what you can do is you can multiply the top equation by 5. So 5 2s are 10, you will get 10 electrons. And you can multiply the bottom equation by 2. So you will end up with 10 electrons as well. So 10 electrons at the top, 10 electrons at the bottom. So you can go ahead and simply cancel out your electrons then. So that is what I'm doing. So first we will multiply the top equation by 5. So this is going to end up becoming, 1 minute, let me just, this is going to end up becoming 10 iodide ions or 10 I minus gives us 5 I2 and 10 electrons. So that is what will turn to your equation number 1. Let's do equation number 2. So we're multiplying all of equation number 2 by 2. So over here you will add a 2. You have 8 hydrogen ions. So if you multiply 8 by 2, you will get 16. So you write down 16. You have 5 electrons. 5 multiplied by 2 is 10. So you will go ahead and write down 10. Then you have Mn2 plus ions, manganese ions, which are only 1. So you multiply those by 2 and you end up getting 2. And then you have 4 H2O. So multiply 4 by 2 gives you a total of 8. So you write down 8. So now what happens is that since you have 10 electrons at the top of the equation and 10 electrons at the bottom of the equation, you can go ahead and cancel them out. Once you've cancelled out the electrons, you will write down the rest of the equation as it is. So you will write down 10 iodide ions plus 2MnO4 plus 6 hydrogen ion give us, so everything that is
Hydrogen ions?
16 hydrogen ions, yeah, gives us 2Mn2 plus 8H2O plus, we have to write this down as well, 5I2. So this is going to end up becoming your overall balanced equation. Making sense?
Yes.
So yeah, making sense?
yeah.
Okay, all right, let's take another example. Hold on. Okay, let's take another example. I'm giving you guys I'm giving you guys two half equations. Okay, so this is one half equation. This is equation number 1 and this is equation number 2. what you guys have to do is you guys have to go ahead and give me a total balanced equation. So how can we go ahead and do that? So what do you think? How can we go ahead and add the two equations together to get a total balanced equation?
So I guess first the equation below we should multiply it by 5 so that the electrons become equal.
Exactly. So you multiply the equation below by 5. So what will you get? 5Zn. Give this 5Zn2. And this is going to end up becoming 10. Good job. So you will go ahead and multiply the equation at the bottom by 5. Now, since the electrons are now balanced, you can cancel them out and add the equation together. So everything before the arrow. So before the arrow, what is written at the top? 2iO3 minus. What is written? 12H plus. What is written at the bottom before the arrow? 5Zn.
5Zn.
Exactly. And then we put our arrow and then we write down everything that is written after the arrow. So at the top, we have I2 plus 6H2O. And at the bottom, we have 5Zn2 plus. So this is what your overall equation is actually going to be. All good? Any confusion, guys?
Not for me.
Hold on. Do we have more complicated ones? All right. Let's take a look at another example. So we have these two half equations. Okay. Let's take a look at it. One half equation is MnO4 minus plus 8H plus 5E gives us Mn2 plus 4H2O. This is one half equation. This is the second half equation. H2O2O gives us 2H plus O2 plus 2 electrons. Now we have to go ahead and balance it. Zoya, what can we do over here to balance the total number of electrons? See the number of electrons we have at the top equation and at the bottom equation.
We can
Yeah.
leave the first one as it is and multiply the second one by 4.
What will you apply multiply the top one with? The first
Nothing.
equation. You're saying let's not multiply it with anything?
Just wait. It's plus 5e minus.
Yeah, 5e minus. Yes. I'm sorry if that's not clear.
Okay, then we can multiply that by 2 and the second one by 5.
Exactly. So you multiply this by 2 and you multiply this by 5. So what do you get? You tell me and I'll write the numbers down. So what will you do? The MnO4 minus, what do I put next to it?
2.
Good job. And then after that?
That's right.
Yeah, that's 8. So that will
So
become
16.
good job. And then what will happen after that? The next one,
10.
the electrons will become 10. And then after that,
2 Mn2 plus.
and then
8H2O.
good job. So that you've done equation number, you've done your first equation. Good job. Now for the lower one, how will you write it down?
5H2O2.
Yeah. And then
10H plus.
10H plus. And then
Plus 5O2.
plus 5O2 and
Plus 10E.
10E. So we will write down 10E. Now, We can cancel out the electrons because this is 1 electron and this is 10 electrons. We can cancel those two out with each other. Can we also cancel something else out? So is there something else that is present? For example, in one equation, it is present before the arrow. In the other equation, it is present after the arrow.
The H plus ions.
The H plus ion. Over here, you have 16 H plus ions, and over here, you have 10 H plus ions. So you can also cancel them out. When you are talking about cancellations, they have to be on opposite sides of the arrow. For example, the 10 electrons at the top, they are behind the arrow. The 10 electrons at the bottom are after the arrow. So since they are on opposite sides of the reaction, you can cancel them out. So hydrogen ions in this particular situation are also on opposite sides of the equation. So you can also cancel them out. So first of all, okay, so yeah, just go ahead and tell me how we're going to write down our final equation. We'll go over the hydrogen part later. But first of all, just start dictating to me how we're going to write it down. So everything that is before the arrow, just tell me all of the reactants on the reactant side.
So 2MnO4 plus
Yeah.
5H2O2
Plus 5H2O2. And what else is on the reactant side?
plus we're canceling the 16 and the 10 out, right?
That would be ideal, exactly, since the 16H plus is on the reactant side and 10H plus is on the product side, so you can cancel them out. So if you do
Wait,
that,
so
you will
what-
simply do 16 minus 10. What will you get?
So 6, right? 6H plus.
Good job, correct. Now tell me everything that is after the reactant or what is in the product.
2Mn2 plus 8H2O and 5O2.
And that is it. That's how you make your balanced equations. So that is how you're going to be making your overall total balanced equations. All right. So, okay. Go ahead, take a look at another equation. Let's practice one more. Fe2 plus gives us Fe3 plus electron. And then the second equation is MnO4 minus plus 8H plus 5 electron gives us Mn2 plus 4H2. Okay, so now, Zoya, how are we going to go ahead and first we need to balance the number of electrons. So what will we do?
Is that 4 and 5?
Where? Sorry, this is 2 plus. This is Fe3
Let's know
plus.
the number of electrons.
No, that's plus electrons.
Oh, that's plus. And then the next one is plus 5e.
5e.
Okay, so we can multiply the first equation by 5.
Good job. Multiply the first equation by 5. So what is going to happen to the first equation? Just tell me. What are the values we're going to get?
So 5Fe2 plus
5 Fe2 plus. Good job. Will give you
will give you 5Fe3 plus
And?
5 minus.
plus 5 electrons. Good job. Okay. Now what you have to go ahead and cancel out your electrons, because at the top electrons are on the product side, at the bottom electrons are on the reactant side, so they can be cancelled out. Now, I don't think anything else can be answered.